Right, so this chapter, this section, I should say, is on polynomials, mostly just graphing polynomials. At least pretty much all the information that we're going to get from these is with the intention of being able to draw the graph, or in the case of this WebAssign homework, identifying the graph, because these are all multiple choice. So let's talk about what a polynomial is. A polynomial, which we looked at, I think, when we talked about quadratics, has this form here. The important thing to remember is all of the exponents are non-negative integers. So 1, 2, 3, 4, 5, so on. And then this leading one is not 0. That's not super important. But all of the A's are called coefficients. The last one is called the constant coefficient or the constant term. And then this first one, or whichever one has the highest exponent, that's called the leading coefficient. And then, of course, the degree of the polynomial is determined by the highest exponent. So we have an example here. And you can see the leading coefficient is 3, the degree is 5, that's the highest exponent. We call that term the leading term. And then we have the constant term, and then 3, 6, -2, 1, 7, -6. Those are all the coefficients. Technically, I think -6 is not a coefficient, but I guess that's a little bit less important. So it's kind of important, be a good idea to make sure you know these basic graphs. So these are all the polynomials getting higher up in degree. So you have y equals x, x squared, x cubed, x to the 4th, x to the 5th. Notice, so excluding this one, although we could kind of talk about that one as following the pattern as well. But usually when we talk about polynomials, we're not usually talking about linear functions, although they are polynomials. But if we notice the even polynomials here, they have basically the same shape. The difference is the higher the exponent or the higher the degree gets, the flatter it gets around 0, and then also the steeper it will rise once you get away from 0. But the even polynomials all have that same basic shape. If you start adding terms, all that does is, well, it doesn't really do anything to the quadratic. That the quadratic will always have that shape. If you start adding terms to this one, you might have some turns. We'll talk more about that later. Then the odd degree polynomials, they both have the same basic shape. If you went to x to the 7th, it also had the same basic shape. The difference, same as when you increase the even degree, same thing happens when you increase the odd degree. It gets flatter around 0, and then it gets steeper quicker as you move away from 0. So make sure you know you can identify the basic shapes. And then we talked about transformations before, so the same rules kind of apply for transformations as we go. So for instance, adding a constant on the end moves it up. Adding a constant or subtracting a constant inside with the exponent, so x minus 3 cubed would move it left or right. Putting a negative in front flips it upside down. So all those still apply, but we're going to be looking at more complex polynomials, so not just a single term most of the time. So we'll have different ways to kind of graph these besides just using transformations. But here these first couple examples, we are going to use the transformation. So negative x cubed. So the x cubed on the previous page looks like this. The negative in front is going to flip it upside down, and so it's going to look like that. Now, it may be hard to remember. Obviously, if it's an x squared and you have one that looks like that and you flip it upside down, now it looks like an n. That's fairly easy to remember. These are the same. Yeah, they're kind of more similar and harder to differentiate. The way I remember this is if you here's the x cubed, so we have a positive coefficient there. If you connect the ends, and technically there is no end, but if whatever you drew, you connect the ends, this is a positive sloping line. So we have a positive coefficient. Whereas on this one, this is a negative sloping line that connects those endpoints. And so that would be a negative coefficient in front. Next, we have x minus 2 to the fourth. So x to the fourth looks like this. We have a pretty flat bottom around there at 0. This is going to move it to the right. And so it's just going to look like that. So same transformation rules, shift 2 to the right. And then this one here, we have 2 transformations. We have or really 3, I guess. The negative is going to flip this upside down. The 2, if you remember, a number greater than 1 is going to vertically stretch it. And then the plus 4 on the end is going to move it up. So let's move this up 4. This is a negative and it's an odd number. So it is going to look like this. And we could look at, I mean, it's hard to hand draw the vertical stretch, but this is vertically stretched from just a negative x to the 5th. All right. So we'll stop this one here, and then we'll talk about end behavior on the next video.